Okay. Today's date is literally the 19th of July, 2026. The time now is 10, sorry, 12:13 p.m. I'm gonna be speaking on two things here. Why I claim to have unbiased AI. Why I claim to have unbiased AI. I have to find two things, three things here in this video. I have to define. Oh, it's not recording. I have to define three main things. Yeah, define three main things because I'm claiming I have unbiased AI, which is may not be true. So yeah, let me go to speechnotes.com. One second, guys. I think of the paper. Why I claim to have unbiased AI. Yes, why do I claim to have unbiased AI? Uh, yeah, um, basically, the date is the 19th of May, 19th of July, 2026. The time now is 11:15 p.m. Why do I claim to have unbiased AI? My name is Namdi Michael Abana. Why do I claim to have unbiased AI? Define unbiased. Um, Unbiased means no prejudice for and against given the data, given the data set. Um, so for unbiased means uh, for uh, for and against uh, no has no prejudice, has no preference, doesn't deviate. But this is basically ontological based intelligence. How does my AI stop bias? I'm gonna be formally looking at the papers, but it's gonna be uh, a long video explaining why it doesn't have any bias. Uh, uh, you know, why my aim things to have bias. Define unbiased. Unbiased. Unbiased again is having no prejudice. Uh, basically, this term prejudice is like, what can that mean? That doesn't really mean anything in the kind of formal setting of the world. I have to look at the papers stuff. So today I've got the papers here. I'm going to explain the core explanation in case any kind of thing get lost. The prejudice is basically the scoring of the scoring of the algorithms. So you got A star scoring. You got kind of scoring algorithms that measure rank or depth or closeness degree to country so centrality algorithms. What I'm trying to get at is that you got algorithm scoring, which rank uh, systems. I'm gonna give you an example of a scoring algorithm. A scoring algorithm. Um, so let me give you an example. Say you want to search the word bank. You have a word bank of bat, and bang. You're searching for the word bat. The word bat here. If you start with letter B, you know, B. If you type in B, so you have the word bank, like a food bank, or just the word bank, and you have the word bat, BAT, and you have the word bang, BANG. These three words are, on a linked list on a tree. So traversing the tree, you have uh, BANK. You have BAT. And you have if you talk about root right, root left, root left right, root left right, and you have BANK, BAT, and BANG. Yeah. So a scoring algorithm here we use we take this tree, or if you have a regular, so you have say you're now searching a B, and you're using a star algorithm, BA, I mean Dijkstra's closest algorithm. Let's say Dijkstra's, that is closest essentially. You have B, you get A, you get B, you get A. If you type the next word will be A. You type in A, you get T, T, T or T or N or T N, T or N as the next word. Yeah. If you type in T, you've got the word. You know, but you can select between. You still have the placeholders T and N. So this is the word graph. The scoring of T and N is one word, is bat, is the one, because the ratio, there's because it's a ratio between 0 and 1, because it's probabilistic, it's a ratio of 1, it's a ratio 0 and 100%. So BAT, or this is 50-50, so it's a weighted average between the closeness of two words. So if you have no, am I wrong? So if you have T, bat, and you have bat or N, T and N, you have 50-50, 50% of the. Am I wrong? I'm not sure. Of the two words between T and N. So that is like a until a structure that is bat, you will have a 50-50%. Now you need the G's not there because there's no you can't score this. There's no score, it's just 0%. So you will not be able to see this on your word list. Now, if you use the regular expression and search A, I'm searching for bat, I type in bat, BAT, I get bat immediately, but I pick bat. If I'm searching for bang, let's say bat, if I'm searching for bat, I put B, wildcard or star, star will give me BANK, uh, BAT, and BANG. But if I put in BA star and N BA star, then this will match NK bank and bang, because this is the two word, but this is the scoring. So I did give an example. This is scoring in a nutshell. So scoring basically matches the word category, the category. Because if I'm using a regular expression, it will match the word expression between bang and bang. Because so you have limited. It's basically it works backwards too. It's basically a recursive. It's basically a backtracking algorithm. You can backtrack because everyone can backtrack. You can go back divide and conquer and divide and merge solutions. That's what scoring really is. Because you have it in bi-directional ways, like a bi-directional Dijkstra. The name is bi-directional. It's like basically it's like what you use for Google Maps. It's like what we use for Google Maps to search up how two locations from two point. Can score the positions. And another example is bi-directional Dijkstra. Bi-directional Dijkstra algorithm. Because they work on closest neutrality, closest centrality, which is basically the closest nodes that will score you to nearest distance. Nearest distance. The closest node that will score you the nearest distance. Yeah. So that's the first thing I want to get out of the way. The second thing I want to get out of the way is the training model. So you have the divine unbiased state, you have training. So training define text patterns and predict outcomes. Training detects patterns and predicts outcomes. So why I have unbiased AI is because pattern, the prediction of outcomes is easier based on my method of my training method. My training method. So training is the defining detecting patterns and predicting outcomes. My AI systems work on the former predicting outcomes better than the pattern because it doesn't pattern match. It just my AI pattern matches. Yes, my AI does pattern match. Obviously, it's AI, but it's predicting outcomes better than the pattern matches. Because it doesn't need to it predicts solutions to better because and why does it predict solution? This is why my AI is biased. Why does my AI produce solution? The unbiased AI, my AI produce solution because there's three types of solutions in space. There's three types of main ways to do this. Supervised learning, you observe the AI, you supervise the AI, you give some training input, you give some patterns to detect, and give it out. Okay, basically, you supervise the AI, you give it patterns to detect, and predict outcomes to predict. Those are the two main things. You give it patterns to detect and outcomes to predict. You know, you know, and you learn that way. It's supervised. You guide. It's a guided. It's a guided learning method. Unsupervised learning is you give it a bunch of data sets and you go away and you can see basically you unsupervised. Logic applies. Same logic applies in the kind of training, kind of because that's how I remember it. Uh, so you for the best understanding, you give it input data. I'm gonna review the papers today because those papers are very important. You give it input data. You train the model. You with a supervised learning. You give it patterns to predict and patterns to detect. Patterns to detect and wait, is it you give it outcomes to predict, and you walk away. You are basically simpler than it's harder than basically. You give it outcomes to predict. That's supervised learning. So you give it outcomes to predict. So in unsupervised learning, you give it outcomes to predict. But you give it another like a pattern and yeah, to detect. You start to identify those patterns from the data, and you have reinforcement learning. So you send the input to the output, you send the output to the input of the AI system. So you and you said make it better. You iterate. It's a reiterate cycle. The problem with this is that it is not the whole problem with this is that the whole AI system does not know the data set, does not understand the data set to begin with. The data set appears stochastic. It's all stochastic, and that's the problem. The problem with AI being unbiased is that the data set appears stochastic. Let me give you an example. It's a probabilistic distribution once it carries the data, and the AI system has to weigh has to rank basically. The way I have to do it is structural boxing. So basically, if the AI system can can understand this is the structure to this data. This is how the data should look to you. This is what it looks closer to. It's you've really understood the problem of the AI system, what it's building, like in the kind of the sense of word, in the greatest sense of things. Because you got structural unboxing. So the two words to understand here: structural unboxing. Structural means the data is structured or unstructured. But if you're using structural unboxing, you have to unbox insights from the data set. So the AI system cannot just tell you, train the AI system, the AI models cannot just tell you to, you cannot just use the AI model to train the data. You cannot just train the AI model on any data. The AI has to pull its information from the data itself, so it can interpret the data because it's a probability distribution all in the data set. So making a lot of things up, but I'm not wrong about a lot of things I'm saying because I'm still calling it. So you have to pull insights from the data, and the data has to have in a structure. That is why we have structured data. So that structured data is really there, but the structural aspect is like this data is unstructured. You know, we have to put inside. We have to unbox the insight before we can make our predictions. So before my AI predicts, it's algorithmically classify data in clusters because which uses nearest neighbors to cluster the data to something that the model can can be trained upon because I'm not saying the data is already trained. Stay in the best case. So this law is perfectly basically perfectly unbiased. But for the AI model to understand the data, the training method must match the data set. The training method must be a match the data set. It's like the training method must match the data set because you are dealing with neural networks in deep learning or machine learning models. They because you can classify the neural networks. So you want to have a way to KNN cluster to cluster the data. So you have n nearest neighbor algorithm. So n nearest neighbor n nearest neighbor is the nearest neighbor algorithm. Nearest neighbor algorithm that does with the graph coloring. So so you have basically you have bipartite. Bipartite meaning a two-way two column graph. You can have n column graph, which I'm using to define IJK K and IJK like the type of color you can associate with graph. Because for any kind of graph, you can add a new number to the graph, a new dimension of the graph, which represents a new kind of data in the data set. Because the data has been clustered. And because it's in clusters, my data set represents like IJK. So IJK are numeric values which are used to quantify data based on the color of the graph. So if you have one node, one data set colored red, blue, and green for IJK simultaneously, you cannot use these colors. Yeah? You have to create a new color or use shade of color, to handle the kind of taxonomy, language taxonomy of the grammar of the AI understanding it as it's being trained, as it's being trained. So I'm saying that why AI is advanced today is literally because it is trained with the same tools. The tools that are used to train it are naturally biased. Because they color stuff incorrectly. They predict after the color stuff. The color the nodes. They keep color them two colors at once. They don't respect the bipartite two colorable graph in clusters. So they don't expect the bipartite color graph. So because the training method can be structural or unstructured, or let's say structured unboxing. Let's say the term structured. This data, this episode on this data structured. I need only structured data. Don't give me anything that doesn't bring me structured. The AI must be able to categorize that data set and make sure that the prediction match that schema of the data set, so it will come out with the accurate outcome. It's like think of it as types in you must have the same type schemas of data set. So the data set must have a schema to ensure the AI meets drawing prediction and color it predictably. So if you have structured unboxing, you have unstructured unboxing, so you work on unstructured data. Also due to basically random real-world data. So you have unboxed it, which is the paper of the real-world, like unboxed it, like you're trying to get insights from that. So you're unboxing the data to get insights from it or pull out new information that isn't there. Because if they can't color new information, can't color into the pattern predictor. If you can't color, if you can't paint a new picture, make a new outcome, based on the input data set, it's still predicting factor. That's the big thing. Because if you cannot color the graph of the Canaan graph with a new graph color, then it's still predicting patterns, and that's what I'm saying. So it's predicting outcomes. Let me just show you what I mean. So this is what I'm talking about. Here, this video is my work here. So fair. These papers are fair principles. This paper by Alexandria with disparate impact. A study of bias in residential production instruments. What's that one? So this is the paper here. The probability of predictive priority. Yeah. The score of predictivity. Yeah. Yeah. So definition two. So this is definitions here. So I'm gonna go through definitions. Out of this paper. Covariant. Okay, we began with substitution of s equals s theta sx. Let's s is sample data set. Yes, let's x equals sample data of x. Based on the covariance of x equals x, which is the element of real primes RP. With higher values of x contributing to the risk spectrum will highly considerably contribute by each one. For stability, our special of fairness criteria focus on these two groups. Let A be individual belonging. Yeah. So this paper uses predictivity. You can predict something, but it doesn't just the hypothesis my own of fair prediction. So it risk advantage of fair prediction. So it works on fair prediction, but I'm not saying that the fair prediction cut is there is incorrect. I'm saying that this is valid. This is what works. But for it to predict outcome, there has to be a structure. It has to work on the training as well, because it has to be like a feedback into training method, like the training method as well, because it's like that's why I emphasize. It's like the training. I know it's making it up. The training method is you have two steps. You have the training and the data. And data set. If you have a data set, any model, training model or something you cannot you cannot do. Well, you have to colorate, collect. You have to perform. You feel unstructured and structural unbox them. So I'm gonna put this into chat Kimi. Let's see what Kimi thinks. Kimi, I'm reading the paper. I have to read the paper. Why I claim to have one by there? Okay, I'm gonna put the video up. But I'm gonna read the papers. I promise myself I'm gonna read the papers. I'm gonna download them. I'm gonna read the papers. So we got inherent trade-off